Hello everyone and welcome to this presentation on VUnit. My name is Lars Asplund and I'm working with Synective Labs. So the main purpose of a unit testing framework, VUnit included, is to provide test automation. And automation starts with having self-checking test benches. You can achieve this with VHDL search, but you can also use the VUnit check package for getting more extended functionality. In the simplest case, a VUnit check is the equivalent of a VHDL assert. So at the bottom of the slide there, you have a check for a condition, and if that condition fails, you get an error message. But VUnit also provide specialized checks. For example, these two. With check stable, you check the stability of a signal within a given time window, and with check not unknown, you can verify that the signal doesn't have any unknown values. These two are concurrent procedure calls, so they are active on the clock edge, and in this case they are also located within production code, the UART receiver. Now they are only used for simulation and test, so they will be ignored by synthesis. So here is the complete list of checks we have today, and common to all these checks is that when they report an error, they do so by using the VUnit logging package. That package can also be used standalone, like in this example. I've embedded a traffic logger into my UART receiver, so whenever I receive a byte, I will issue a debug message. With logging and checking, you can control where messages goes, to file and or to display. You can control the verbosity, and you can also control the format of the output. And in this case, I've used the verbose format, which in addition to the error message itself, give the time, the simulation time of that message, as well as the location. So as you can see there, UART receiver VHDL file on line 39. This is not functionality you can get from VHDL itself, so VUnit provide a preprocessor to give you this optional information. And it is especially useful if the message comes from a failing check, because then you know where the failure occurred and not only when it occurred. Now, having self-checking test benches is only part one of automation. You also need to automate the execution of your test benches. And in unit testing, we do this with the test runner, which is the main controller of your test bench. So in this case, again, the UART receiver test bench, the test runner is sending messages to a UART driver. Those messages contain commands like transmit the value 17 onto the serial input of the UART receiver. Once the UART receiver receives that bit sequence, it will assemble that into byte again and output that on the T-data output. That can be read by test runner and compared to the expected value. The point of this slide is to show that VUnit doesn't care about the complexity of your test bench. You may have somewhat advanced concepts like transactions, drivers, scoreboards, and so on. But you can also make it simple, like we did on the output, just directly reading from the UART receiver in this case that we are testing. What VUnit provides is structure to your test runner, structure that makes it possible to automate everything. So if we look at the code for this test bench, it starts with the entity declaration, where you have a runner configuration that enable you to configure certain things in your simulation run. For example, if you want to control the output directory where log files are placed, you can do that through the runner configuration. Then I've excluded a bunch of code, for example, clock generators, the UART receiver itself, and the UART driver. And in the end, we have the test runner. Usually you have some setup call in the beginning there, like deciding what kind of output format you want for your logs. But then you have the important test runner setup call, which takes that runner configuration I showed you before. The process ends with a cleanup code, which essentially will force your simulation to stop. And in between there, you have your test code. Now, in case that piece of code hangs, it's important to force the simulation to stop. And we do that with a test runner watchdog at the end of the file, which will force the simulation to stop after 10 milliseconds. The reason is that if you have many test benches that you have set up to run during night and the first simulation hangs, then you've wasted an entire night of testing. The typical structure of test code in unit testing is to divide the code into a number of test cases. And the set of test cases is called test suite. So in VUnit, you can create a while loop like this. And in that while loop, you have an if statement where each branch represents a named test case. Now, only one branch, of course, is active in each iteration. And the reason for having a loop is that then you can put code just before the if statement and just after the if statement that can be shared between test cases. If we zoom into one of those branches, we will see a typical test case. So here I'm creating a test sequence vector. It consists of a number of random integer values. I've created those using the OSVVM library. I loop over that test sequence vector, and for each random value, I send to the UART driver a transmit command with that value. That will result in a number of messages in the UART driver, which will be executed one at a time. Meanwhile, the test runner goes to the output of the UART receiver, telling it I'm ready to receive data, and then start waiting. Eventually, data will arrive, and the received data is compared with what is expected from the test sequence vector. Now, this is a test bench that you can run in your simulator, but we recommend that you take this one step further and create a Python run script. So don't worry, you don't have to know much Python in order to do this. Creating one of these scripts is more or less a copy-paste exercise. So if we start to look at line 3, I'm creating a VHDL library called uartlib. And to that library, on the next line, I'm adding all the VHDL source files in the source path. I'm also creating a library for my test bench files and add to that library all the VHDL files in my source path /test directory. After that, I have a method for adding OSVVM to my project. OSVVM is shipped along with VUnit, so there's a special command to do that. And in the end, we have a call to the main method. So main will scan for all your VHDL files, figure out their dependencies, and see if something's changed since last compilation. After that, it will compile what's necessary and in the order required. It will also scan for test benches and test cases. So you saw the UART receiver test bench before, but there's also a transmitter test bench within these files. And then I will run all those test cases. In this case, we have 2 failing test cases. The first test case in each test bench fail. The interesting part here is that one of those test cases caused the simulator to crash because it was a division by 0. VUnit will detect that and restart the simulation running test case 2 and 3. So just because you have a fatal error in one test case doesn't mean that the entire test bench needs to crash. Also, if you restart the simulator in between test cases, you also prevent the cases where you have a failing test case, which didn't cause the simulator to crash, but you prevented that error state to propagate into the next test case, causing secondary failures, because that would give you a report that will indicate more problems than is actually the case. Now, when I have a bunch of scripts, I run those continuously as I'm developing my code. So for example, if I'm adding code to my UART receiver, I'm running the test case for that. I'm adding more test cases, but I'm also running the script for the transmitter code because they are closely correlated. And I want to make sure that what I'm doing in the receiver doesn't affect the transmitter. Now, there's also a need to run all test cases in the entire project once in a while, because there may also be other parts of the design that are affected by your changes, but you didn't realize that. And a tool that can help you to manage a large set of test cases and test suites is a tool called Jenkins. Open source, heavily used within the software community. It can manage when tests are run, for example nightly, or whenever someone checks in a new piece of code. It can also help you to distribute those tests onto different machines, so you get a faster response time on those test runs. And of course, it can present the results. Now, Jenkins can really do any type of automated tasks, so it can also help you, for example, to do automatic builds of your FPGA. So here's a view what the web GUI of Jenkins looks like. You have a list of your test suites, and you can see the current status. You can click on those to get the result for individual test cases and so on. Now, this is all I'm going to say about VUnit today. If you want to get started, you can download VUnit on GitHub. There you also will find more examples and videos. We try to be a very active and responsive community, and we would like you to participate as well. And you can do that by, for example, asking questions, reporting bugs, suggesting enhancement, and of course you can also contribute code. So again, this is the point to get started, and thank you for listening.